All right, you ready, gentlemen?
Yes, we are.
Well, without further ado, I give you Saurabh Kulkarni and Dung Soo Lee. Give them a big round of
Perfect.
applause. Woo!
Thank you, everyone. Hey. Thank you all for taking the time. And after this great build-up, I am very happy to be here and talk about some of the excellent work that we have been doing when it comes to data center AI. For introduction, my name is Saurabh Kulkarni. I lead strategy and product management for all of our AI, data center AI, product portfolio, and roadmap. So with that brief intro, let us get into it right away. The talk today is going to be focused on Gaudi 3. We are very excited to keep you appraised of the progress that we have made on Gaudi 3 over the past year or so. Just as a refresher, what is Gaudi 3? We offer Gaudi 3 as a data center AI accelerator to power your AI innovation, to help our customers build applications that leverage the excellent processing capabilities of Gaudi 3, both at the software and hardware level, and give them choice and optionality to offer cost-optimized solutions for AI for their respective use cases. As far as the product itself is concerned, at the hardware level, we offer it in two form factors, which is the OAM form factor that we put on a universal base board design with 8 of those OAMs connected in an all-to-all fabric on the UBB, and we build rack-level solutions with that. And then we also offer Gaudi 3 in a PCIe form factor. That product will be coming out in about a quarter's time. We are very excited to offer that as well as a means to lower the barrier of entry for customers who want to start small and then scale big because of the low TDP and the highly cost-optimized nature of inferencing solutions that Gaudi 3 will enable with the PCIe card. So what does Gaudi 3 bring to the table as far as the end user is concerned? First and foremost, it's excellent price performance for AI use cases. We have done a bunch of benchmarking against the market leader in this space, comparing Gaudi 3 performance against the H100, H200 grade GPUs from NVIDIA. And by virtue of our lower price point on Gaudi 3, we offer great performance per dollar advantages over NVIDIA's latest and greatest products. Beyond that, we obviously are very, very keen to offer scalability with Gaudi 3 so that customers are able to scale their solutions at the data center scale depending on their use cases without any sort of a vendor lock-in. We are strong advocates of an open ecosystem across hardware, infrastructure, and software, and we continue along those lines as far as our Gaudi 3 product line goes. And we will not stop at Gaudi 3 with that kind of an objective in mind. We will continue our approach towards data center software and hardware through enabling an open ecosystem even on our future products, which we will talk about at a future session. And finally, this is all about integration of software, hardware, and systems. Our strategy is built on these 3 key tenets because it's not just a silicon play. It starts with the system, it starts with the software, and then it all trickles down to the actual component. I will now play a short video that will give you some insight into how we look into building scalable systems with Gaudi 3. This video will walk through how modular the system design for Gaudi 3 is, starting small with a single server and then growing big using our scale up and scale out networking methodologies. So if I could get this working. Uh-oh. Somehow the audio is not working. I will just do a voiceover. So what you see here is the basic construction of a Gaudi 3 server, which is 8 of these UBB, 8 of these OAM modules in a single node. What we can do is build them in a small cluster or a mini cluster that has up to 512 nodes or 4,096 clusters or 4,000 Gaudi 3s in a single cluster under a single network or a single network topology with 2 layers of switching. So what this shows is, by virtue of a common backbone that is Ethernet based for both scale up and scale out, we're able to scale Gaudi 3 systems starting all the way from a single server to up to 4,000 of these Gaudi 3s in a single cluster, offering redundancy and reliability in the form of 3 independent network spines that you see in the 3 colors shown in the figure here. But that's what Gaudi systems of today look like. But what's coming in the future? I am very excited to announce that we are hard at work to bring out Gaudi 3 in a rack scale form factor to continue and adopt to the industry trend of treating the rack and the data center as a unit of compute. So as you see in the picture here, this design comprises of 64 of the Gaudi 3 accelerators in a single high bandwidth domain, or a scale-up domain, like we call it, that leverages the same Ethernet-based RoCE network for scale-up that is assembled in a single rack. What this enables is a collection of 64 of these Gaudi 3s in that high bandwidth domain that offers up to 8.2 terabytes of HBM2E memory at the rack level, at an incredible amount of bandwidth to memory, which is about 77 terabytes per second of memory bandwidth at the rack level, and all of that in 120 kilowatts of rack level power budget. Now, while I say that this is a 64 Gaudi 3 rack, we do recognize that customers may have varying needs for the rack density based on their power and cooling requirements, which brings me to modularity and scalability. This design is highly modular, which means that if there is a lower TDP point that a customer wants to deploy in the data center, we can go down to 32 of these Gaudi 3s in a single rack, or potentially go down even smaller, down to something like a 16 Gaudi deployment in a single rack. The key is modularity and scalability. As you can see, the architecture is disaggregated, meaning there is a separate compute track or compute tray, which has CPUs and GPUs in it, and a separate network tray or a switch tray that disaggregates the compute and the networking. This is the fundamental building block which opens up a lot of options from a modularity standpoint. We are focusing on inferencing and fine-tuning use cases with Gaudi 3, but we also do support training of smaller scale models at this rack scale level. And then beyond the rack, if customers want to build larger clusters, they can build those leveraging scale-out technology, which is also based on stock Ethernet, which is quite an open and ecosystem-based approach that we take, as opposed to our competitor, which is a vendor lock-in proprietary approach towards building these scale-up networks. So I've talked about Gaudi 3 a lot, but I'm sure a lot of you are wondering what's next after Gaudi 3. As you see here, Gaudi 3 in the 3 form factors will enable customers to address their needs for inferencing and fine-tuning. But after Gaudi 3, in the 2027 timeframe, we will be introducing a fully programmable general-purpose GPU in the form of Jaguar Shores to the market that will be based on the next generation of our programmable IP for GPUs called the XeIP. I will not talk in too much detail about the Jaguar Shores product line at this time, but as and when we get closer to the product readiness for Jaguar Shores, we will share more details on what that product is all about. We are very excited about Jaguar Shores being a highly competitive product in the market, addressing the needs of both inferencing, also starting with inferencing, leading with inferencing, but then also taking on training at very large scale in that time frame. Now, I can talk all I want. I can talk all day about the progress that we have made at Intel on our product line, but nothing speaks more than a customer testimonial or a testimonial from a close partner. And NAVER has been one such partner for Gaudi, who have been in a deep engagement with us for quite some time now. And it gives me great pleasure to welcome Dr. Dong-Soo Lee on stage here with me. We are very honored to welcome you, Dr. Lee. Dr. Lee is VP of AI R&D at NAVER and is going to share his experience on Gaudi products with you. So welcome, Dr. Lee. Thank you for your close partnership. We deeply value the collaboration and would love to hear your thoughts today about the partnership that we have ongoing.
Thank you for having me. So NAVER Cloud is very excited about our partnership with the Intel to foster open and cost-efficient AI ecosystem.
Perfect. So to start the conversation, Dr. Lee, can you share with us what was NAVER's primary objective in partnering with Intel and leveraging Gaudi AI or Gaudi accelerators for your AI needs?
Yeah, of course. So, by the way, for your information, NAVER is considered as #1 Google in Korea and #1 IT company. And NAVER Cloud is pretty much interested in affordable and sustainable AI ecosystem and services. So after confirmation that Gaudi shows very strong performance in basic functions like a matrix multiplication, we initiated Intel NAVER collab. So by the way, I'm a director. And through the collaboration, we could optimize software for the inference using Gaudi 2, and we could achieve very, very competitive performance in VLLM inference framework. And not only that one, but also we initiated the R&D program with top Korea universities. And through the collaboration, we demonstrated the power efficiency and programmability, many benefits using Gaudi 2 through the top-tier conferences like ICLR, ICML, CPPR, and so on. So we could get lots of benefits from support from Intel for AI infrastructure and so on.
Yeah, that is great, Dr. Lee. We really, again, can't thank you enough for the collaboration. We are very excited on the work that you and your team are driving on pushing the boundaries when it comes to AI through work with our partners in academia and also advancing research in this front when it comes to leveraging Gaudi 3 for AI. So now that we've talked about the objectives, can you share a little bit about what your experience has been on Gaudi accelerators so far?
So Gaudi, we are pretty much interested in a scalable and robust and reliable AI system, especially in the rackscale AI system. And I think Intel has shown very much a successful demonstration in reliability and performance in the HPC and AI market. And I think Gaudi 3 continues that kind of story, not only for the Xeon. And so we are going to share our own experience with the NVIDIA ecosystem. We could learn so many things, how to optimize AI services and training. And we are going to see the same thing in the Jaguar source and the software ecosystem we are going to develop together continuously.
Absolutely. And we look forward to taking the next step in this collaboration as well. Obviously, Gaudi 2 and Gaudi 3 will be great stepping stones towards that. But we look forward to extending that collaboration in the Jaguar Shores timeframe as well to foster innovation in the AI chip technology industry, because we all know that the industry is looking for optionality, looking for choice, and nothing speaks better than what we are doing in collaboration with NAVER. Now, Dr. Lee, we know we have established this NAVER Intel collab, or NICL as we call it, as a joint collaboration project between the two companies to advance Gaudi and help Intel on the software development aspect on Gaudi 2 and Gaudi 3. We have learned an incredible amount through that collaboration, and through several research papers published so far. We already are reaping the benefits of generating a lot of mind share in the community at large when it comes to AI on Gaudi. So, which is fantastic to hear. Can you elaborate on a few noteworthy outcomes of this NICL initiative so far for our audience to learn more?
Yeah, so the biggest benefit having the Gaudi 2, especially for the inference, is power efficiency, especially for memory-bound workload. So after the emergence of reasoning-based AI model like DeepSeek or O1 from OpenAI, the important thing is we have more and more tokens for the reasoning, so that output tokens become very, very expensive, and we are supposed to produce a lot of output tokens that have inherently low utilization during the AI service. So that's why we focused on the energy efficiency, as we demonstrated the energy efficiency in the ISCA paper, which has been recently accepted. So that way we can come up with like even the hybrid architecture, prefer for very high computational power and energy efficiency for decode. We can generate lots of different kind of scenarios using Gaudi, so that way we can see we can facilitate the AI ecosystem not only with the NVIDIA ecosystem but also with the Gaudi system. So we are very excited about the kind of future new direction with for the especially the reason-based inference scenario.
Perfect.
So on the other hand, I know Intel's so customer engagement and the feedback. So how this collaborative efforts influence the roadmap or product development in Intel?
Yeah, that's a great point, Dr. Lee, and I will be very happy to share that all of the feedback that is provided by partners like you definitely influence our product decisions for the future. We have learned an incredible amount. All of the work that has gone into more efficient from a power perspective and a millimeter square perspective computation for AI through leveraging lower precision data types. All of that influences our product definition for the next generation, which actually we are seeing in action as we define Jaguar Shores and as we fine-tune the definition of that product, both at the component level and at the system level, to advance more power efficient and more cost efficient AI in collaboration with you. So we certainly value that quite a bit. We certainly appreciate all of the feedback that you have given, and we look forward to the next phase in our collaboration to further data center AI for the benefit of not just us mutually, but also for the wider AI community. So with that, I think we are close to the end of our allocated time. Any closing thoughts from you, Dr. Lee? If not, we can hand it over to the audience for any questions that they may have.
Thank you so much. I just learned a lot during this event, and I'm more excited about the future of our collaboration.
Absolutely. Thank you, Dr. Lee. Please stay tuned on our future product announcements. We are very excited to embark on this journey to advance data center AI for the wider ecosystem. Any questions that I can take at this point?
Don't be shy. Raise your hand. If you got a question, I'll come over. No? All right. Well, if you want to approach them afterwards, they'll just stand off to the side. You can answer. Let's give a big round of applause.
Thank you so much.
Thank you, gentlemen, for a wonderful presentation.
Thank you for your time.